Hello, everyone, and welcome back to the Gen Chem Fundamentals series presented to you by MCAT Genie. So today we're talking about a very important concept within general chemistry, and it's called balancing equations. So to preface this video, what's the importance of balancing equations? Why do we even concern ourselves with that? And the key is the first bullet point here, which is the law of conservation of mass. So this law was discovered sometime in the 18th century and has been holding true ever since. And the truth is that with the universe, not only do we have a conservation of energy, which you may have learned already, but we also have a conservation of mass, which means that when a reaction occurs, and lots of chemistry, if not all of it, is based off of reactions, either physical or chemical. Specifically, when you have a chemical reaction, there is a change in the chemical structure of the reactants, which results in a certain amount of product. If you look at the example below, which are hydrogen gas and oxygen gas as reactants, both in their natural diatomic states, which form water as a product, then you can tell that we have two hydrogen atoms and two oxygen atoms in each of those diatomic molecules. But when I draw the product, can you notice what's wrong? Well, pretty clearly, when you take a quick look, you can see there's two hydrogens, which seems balanced, but there's only one oxygen. So where is the other oxygen going? The key is to associate the correct coefficients, not subscripts, coefficients, in front of the molecules to balance the reaction. So if I was to rewrite this reaction in a balanced way, how would I do it? So the first step is to write out the unbalanced equation as we have. Okay, now that we already have that, where do we go next? So the second step is going to be balancing the atoms for the elements that appear only once on each side. Now, in this case, we have a simple reaction, so it's not too difficult to see that. But you can notice that there's only one oxygen available to us, and that has to be a part of water. And we know that because that's the unbalanced reaction that we wrote down. So how do we balance the oxygen? When you look at the hydrogens, you can already tell there's two. So how do we balance the oxygen? Well, bare minimum, we'll have to start by putting a 2 as a coefficient in front of H2O to be able to balance the oxygen. So now there are two oxygens going in as a reactant, and this 2 is applied to that oxygen right there. So we have a minimum of two H2O molecules that must be created as products. Keep in mind, please, that fundamentally speaking, you are not allowed to put a 2 as a subscript next to the oxygen because that would change the molecule. H2O2 is actually called hydrogen peroxide, which is completely different than water. So we're not allowed to put a subscript next to any of the atoms or change the chemical compound or structure in the unbalanced equation. When we are balancing, we must change the number of molecules or atoms that are either reacting or being produced. So now that we've balanced the oxygen, you may have noticed that we've disturbed the balance of the hydrogens because now we put a 2 in front of the H2 and there's only one H2 here. So naturally, doing the same process as we did, we're just simply going to add a 2 in front of this, the H2. So reasonably speaking, if we were to visualize this again, this would be a much better representation of what the real balanced equation would look like if we're expecting whole numbers. So n equals 1, n equals 2, 3, 4, all whole numbers that can be used as reactants or used as products because we're assuming that there are no half or fractional or decimal atoms or molecules, only whole numbers. The same way that when we talk about human beings, you would expect people to be a whole number. So one person, two people, three people, rather than half of a person or one third of a person, if that makes sense. So why don't we move on to a different example to increase the difficulty slightly? In this reaction, we'll be seeing, maybe you might recognize, methane reacting with oxygen, which is going to create carbon dioxide and H2O as products. And this is very, very well recognized if you are familiar with combustion reactions. So when we combust methane using oxygen in the presence of oxygen, We add a little bit of energy, maybe a spark, and we get the reaction started, then we should form carbon dioxide and water as byproducts. So what would be the easiest way to be efficient in balancing this reaction, especially on the MCAT? So in this case, let's take a look at the carbons. Well, there's only one carbon on each side, so there's not much we have to do for that in the beginning. Let's take a look at hydrogen. We notice that there are 4 hydrogens in methane and 2 hydrogens in water. So it might be a good idea to put a coefficient of 2 in front of water, H2O. And last but not least, we have oxygen, which we notice there are 2 oxygens in the diatomic gas as a reactant, and there are 2 oxygens in carbon dioxide as a product, and there's 1 oxygen in water. So in this case, the smartest thing to balance first would be the hydrogens because it only appears in one place in the reactants and one place in the products. That just happens to be the case here. So once we've done that, then that's going to change our oxygen count on the product side. So now the total count here will be 2 oxygens in carbon dioxide and 2 oxygens in water, which is 4 oxygens on the right side. So to balance that, I'm simply going to put a 2 in front of O2, like so. And when we check everything, it appears that we now have a balanced reaction. So not too bad. So if we look at the carbons, they're balanced. If we look at the hydrogens, they're balanced because we started with that, and the oxygens were not too difficult to balance either. So let's go ahead and try another example here. And if you'd like to, please pause the video and try balancing this one by yourself. So hopefully you went ahead and gave it a try. And let's take a shot at balancing this ourselves. So when we look at the reaction, it appears we have aluminum as an atom plus HCl, hydrochloric acid. They're reacting to form aluminum chloride. And I notice that there are 3 chlorides and hydrogen gas diatomic as a product. So where should we start to balance this? Well, it looks like the aluminum is even on both sides. There's only one. If we move on to hydrogen, we notice that there are 2 hydrogens in the products and 1 hydrogen here. So we might possibly want to balance that by putting a 2 in front of HCl, but we'll hold on that for a second. And the other thing that we notice is that there are 3 chlorides in this ionic compound here. So it puts us in sort of a dilemma. If we're to focus on the chlorides, then we would have to throw a 3 in front of HCl to balance the chlorines on both sides. However, now the hydrogens are unbalanced because there's a 3 in front of HCl and a 2 in the subscript of H2. So the question is, what do we do? And maybe you got stuck here. Well, the easiest solution to this issue would be to take a look at the 3 and take a look at the 2. And since we have to get whole numbers, then maybe the smartest idea would be to find the least common multiple of 3 and 2, which, if you multiply them, is 6. So let's go ahead and just throw a 6 in front of HCl and do the rest from there. So this would naturally have to be a 2 in front of AlCl3, and this would have to be a 3 in front of H2. And then that means that we also need to balance the aluminums because we threw a 2 in front of that, so I'm going to throw a 2 here as well. The way to double check and make sure that you balanced correctly is that when you try to divide the coefficients, these must be the simplest possible coefficients and cannot be simplified further. So for example, if we had got 4, 12, 4, and 6, well, all of these can be divided by 2, therefore our job is not finished if we were to get that as an answer. But when you have 2, 6, 2, and 3, if you were to divide by 2 or 3, you would get a fraction at least once. And that would indicate to you that you have achieved the simplest possible balanced equation. Balanced reactions will be necessary for redox reactions, for acid-base reactions and neutralizations, for combustion reactions, as we saw before, as well as precipitation reactions, where we'll have to be careful and take a look at the physical states. such as aqueous or solid. Balancing reactions becomes quite important when we move on to stoichiometry and limiting reagents, which I'll explain further in the next video. Whenever you come across a reaction that is written out on the MCAT, I want you to pay careful attention to whether or not it is balanced. That should be the first question in your mind. If the reaction is not written out in a nice way, where you can see it easily, like this, and it's written out in words, then your job immediately is to convert it into this, especially if it's a 1 or 2-step reaction or a multiple step reaction. We will discuss net ionic equations and net equations in the future when we deal with intermediates, for example. But for now, I hope that this suffices in terms of giving you simple examples of balancing equations on the MCAT. And thank you for watching, and see you soon.